In the previous lesson, we learned how to make this simulation of a coin flipping experiment. And we also implemented our procedure of detecting whether a coin is biased or not after each flip in our experiment. And we also learned how to understand these very nice graphs that visualize this simulation. Now in this lesson, we will play around a bit with the parameters and doing so simulate different scenarios. So let's get into the code and do exactly that. And we begin by looking at the scenario of a very biased coin. Let's say, for instance, that we're looking at a coin that only shows up heads 10% of the times. So the only parameter that we need to change is this p head, this fundamental property. And all of the rest remains the same. So we can just run this cell and see what we get. Now the first thing we see, of course, are our overall results, that after 100 flips, we had only 12 heads and 88 tails. Now all of the information for each flip is contained in this table. But of course we want to look at this figure because it contains all of this information. And of course this is very clear. We see a lot of red bars because of course the chance of getting 8 tails is 90%, and only sometimes we see a green bar. Now correspondingly, we see that in these first few flips, because we get a lot of red bars in succession, that our p-value drops significantly. And after 6 flips, it drops below 0.05. And thus, also after 6 flips, we can conclude that this is indeed a biased coin. Now we see, of course, that this p-value briefly pops up above this 0.05 level. Now why is this? Well, because we got 2 heads in a row. Now, if the probability of getting 1 hit is 10%, then getting 2 in a row is only 1%. And this very extraordinary event makes it so that our p-value flares up just a little bit. But then, of course, come all the tails again, and our p-value basically drops to 0. Now, we can do this experiment over and over again, and we will see that almost all of the cases, we will almost immediately find that this is a biased coin. Now, in this interesting case, we see that there is still some doubt about whether this coin is biased or not within the first 10 flips. And this is of course because in the first 10 flips, we still have 3 times that the coin turns up heads. And thus in the first 10 flips, we have 3 heads and 7 tails. And this outcome is not at all that unlikely for a fair coin. And that is why the p-value still at this point struggles a bit. But then of course we just have to do more flips to see, of course, our p-value plummet and basically remain at 0. So in these extreme cases, it is very apparent that our procedure really works. But what, of course, if the coin is not biased this extremely, but only slightly? Let's say that the probability of getting the coin showing up heads will be 0.48 or 48% compared to the 50% of a fair coin. So what happens then if we run this experiment? Well, we see, because we're dealing with statistics, that sometimes, even though our coin is indeed biased, we see that after 100 flips, our p-value is still sufficiently large, even very large, such that we cannot reject the null hypothesis that this is a fair coin. And thus we get to the wrong conclusion. Even if we run this cell over and over again, we will sometimes get the right conclusion, which is in this case, but most of the times we will get a false conclusion. Now this is to be expected, because a coin that is biased only so slightly, we expect that we would need a lot more trials in order to detect that. In the same sense, of course, that a coin that was extremely biased can be detected in the first 10 trials or even in the first 20 trials if you want to be sure. However, the less and less it is biased, the more and more trials we will need to be able to confidently detect whether this coin is biased or not. Now, luckily, we can of course change the number of trials in our simulation. The only thing that we have to do is to change this parameter. Let's change it to 500 trials instead of 100 trials. Now, if we run this experiment again, now with 500 trials, we see that after 500 trials, we got 245 number of heads, and the number of tails was 255, still quite close to each other. So we expect that the p-value here at the end will not be sufficient. However, we do see that after flip 66, I believe, our p-value did drop below this threshold of 0.05, but it didn't stay there. Now, if we run this experiment again and again, our p-value does drop below 0.05 and indeed remains there. And this second part, that it remains there, is indeed very large evidence that this coin is biased. Now, of course, because we're working with statistics, there will always be cases where we draw the false conclusion. For instance, in this case, even after 500 flips of this slightly biased coin, we were not able at any point to make a confident detection of 95% that this is a biased coin. However, luckily, of course, in most of the times, 500 flips is enough to indeed detect this. Now, to end off, let's look at one final example, which is quite nice to see, and which answers the following question. If a coin is 100% biased, so let's take a coin that turns up heads 100% of the times. After how many flips can you confidently, with 95% certainty, say that this coin is biased? Now just take an intuitive guess. But remember that each individual flip of this coin will have the outcome heads. So after how many flips do you think that you can be 95% sure that this is a biased coin? Well, we can just simulate this, of course. We take, let's say again, 100 flips, and now we take the probability of the coin showing up heads to be exactly 1. And we run this cell, and we see what we get. Well, of course, the results will be that we get heads 100% of the times. And let's now look at where our line crosses the threshold line. And we see that only after flip number 6 does our p-value drop below 0.05. So even though, for instance, you get 5 heads in a row, you still cannot conclude that this is a biased coin. It's only after a coin shows up heads 6 times in a row that you can determine confidently with 95% certainty that this coin is indeed biased. And of course, this p-value only goes down and well, is basically 0. And this is how, by changing only these 2 parameters in our simulation, that we can get widely different scenarios. And you can learn a lot by looking at these graphs. Now, also for this notebook, I highly recommend that you play around with these parameters to get a feeling of these tests and the nature of statistics. Now, in the next lesson, we will look at a less elaborate example of p-values and statistical testing, but nonetheless, this example will be much more similar to what you will do in your data science job in industry. And this example will be A/B testing. So I will see you in the next lesson.